Hey everyone, welcome back to the channel. In today's video, we are diving into one of the most commonly used regularization technique in neural network, the dropout in TensorFlow. So whether you are a beginner or an intermediate practitioner, by the end of this video, you will know exactly what dropout is, why we use it, and how to implement it in TensorFlow. So let's jump right in. First, let's understand what dropout actually is. So neural networks are powerful, but they have a tendency to overfit the training data. Overfitting means the model perform exceptionally well on the training data but struggle to generalize to a new unseen data. Not ideal, right? To tackle this, we introduce dropout, a regularization technique where we randomly drop out or deactivate a certain percentage of neurons during training. Think of it as a temporarily making some neurons invisible to increase the network to learn redundant and generalized features. Here's how it will work. So during each training iteration, Dropout randomly sets the output of a subset of our neurons to zero. This prevents the network from relying too heavily on a specific neurons and force it to distribute the learning more evenly across the entire network. The key here is randomness. Each neuron has an equal probability of being dropped out, and this is controlled by the parameter called rate. So what exactly rate here is? So rate defines the fraction of a neurons to drop. For instance, a drop rate of 0.5 means 50% of the neurons are deactivated during the training step. However, during testing or inference, dropout is turned off and all neurons are active, but their output are scaled to compensate for the neurons that were dropped during the training. So why is dropout so effective? The main benefit is regularization. It reduces the overfitting by preventing the network from memorizing the training data. Dropout also promotes the redundancy in features learning, as it forces the network to learn multiple ways to represent the same information. So here's a quick comparison of model trained with and without dropouts. Notice how the model with dropouts performs better on validation, and even if it trains us a bit slower initially. Now, let's get a hands-on. So I will show you how to implement dropout in TensorFlow. So let me import the necessary libraries and we'll load the MNIST dataset. So here we defined the multiple dropouts in the very simple sequential API model. And let's compile the model and let's see the summary. So this you can see there are multiple layers here. We have a dense and dropout of zero point 0.4, then zero point 0.3 and zero point 0.2 means 20% dropout at the end. Let's train a model. So this example shows a architecture with three hidden layers, each followed by a dropout layer. And we have used different dropout rate to experiment with how much regularization each layer needs. So let it run and complete the training. right? As you can see, the accuracy is increasing with each repetition and the loss is reducing. So it's almost completed. And now finally, let's visualize how dropout affects the training and validation accuracy. This can help us to understand whether the dropout is improving the generalization or not. Right. So let me evaluate. Let's evaluate and see what the test accuracy is. Right. So we have almost like 97%, which is really good. And now let's visualize the dropout effect. So as you can see, the accuracy is increasing with the TPOX and even for both training and validation accuracy. So this example like shows the flexibility of dropout in TensorFlow from setting the fixed rate to dynamic tuning with the callback, right? And visualizing its effect helps us ensure you are not just throwing the layers, but actually improving your model generalization. So this expand the code segment not into deeper understanding, but also provide a practical tool to visualize and experiment with the dropouts. Thank you for watching. I will see you next.